Hello, folks, and welcome back to Learn Synthesis with Pure Data. I'm your host, Dr. Lawrence W. Moore, and this is Season 2, Episode 6. And for the next few episodes, we're going to be working with sampling, creating a sampler that can function as a virtual tape looper. We're going to get the mechanism going for it today. This will be different than the granulator. It's a different way, which you can also use tempo to dictate the speed of playback. And it'll be something where we'll see how eventually in upcoming episodes you can add loop points for looping, as well as looping from the beginning and the end. You can set them. And then we'll also be making a scrub so that we can scrub the different parts of the audio and play back from different portions. And then with that being said, we are going to tack on to that how, as just an example, MIDI pitch can be controlled so that you can make samplers where you load in different samples and the different keys you play on a keyboard will play those samples according to pitch zones. So that's all coming up in the next few episodes. So anyway, let's see where we're at right now. We're going to pick up right where we left off and make this basic new module. So anyway, this is where we left off. I basically copied everything to a brand new episode 6 module, but I've copied everything that we've done so far. We have our granular synthesizer called granulator_mono tilde. We have modules.pd where all the modules will go in. And right now it contains the 2 modules that we made so far, the granulator and the one that we made last time, ringmod_mono tilde.pd. So if I open up modules, you'll see that we have, like we had last time, the granulator feeding the ring modulation effect. Now, we're going to kind of leave this like this because this new module that we're building is going to take a little bit to get together and before we can really make it into a true module. So what I'm going to do for now is at least show you the mechanism for how we can make a sampler that records, plays back. We've already done that really, but we're going to use a different method because we have other functions that we can do with this that we weren't able to do with our previous version. So we're going to do new patch, and I'm going to save this to my folder right away. So I'm going to where I'm keeping the PD patches for these episodes, and each episode has its own patch. Basically, with each episode, I copy stuff from the previous episode, put them in a new folder, and then that way I can maintain the progression that we've been doing. So episode 6, I've already copied in everything from episode 5, and now I'm going to save this new module here. And this is going to be called, I'm going to call it for now, tape_looper_mono tilde. Always like to put the tilde at the end for audio modules, so people know it's an audio module rather than a MIDI one. Now I'm going to keep this open. This is going to be our tape looper, but I am going to close our modules patch for now because, oops, we don't really need to see it. And I keep hitting the wrong button. There we go. I'm going to minimize our file view. As you see, Tape Looper is now here. Okay, so it's in this folder, and we'll be able to load it into modules.pd when it's ready to be loaded in. So I am just going to make sure I have a good enough space here for what we're making. Now, I am going to structure this module similar to the ones we had before, where there's going to be a recording section and there's going to be a looping section and all that. And in fact, because I'm going to do that, I'm going to open up directly our granulator module. So go to File, Open, and I'm going to make sure I am on episode 6 here to make sure I'm opening the right one. And what we're going to do is copy some stuff over from our granulator module. Okay, so here you see this appears as a module in the modules.pd patch because of this red border here. We're graphing on parent and bringing this image in as the module that's granulator. And what I'm going to do, let me resize this and move it over so both are on the screen at the same time. Because I'm gonna try to keep them the same size. Good to have modules with size compatibility. Okay. First, we're going to see by right-clicking on just the space, the background here, which is called the background canvas, and we're going to look at the properties. See, this is graphing on parent. We're hiding its name, which would normally appear in the upper left-hand corner, but then that would, obscure the waveform name of the array there. So that's why we hide it. 320 by 240 and margins of 50 by 50. So let's do that over here. Properties. Graph on parent. Um, 320, 240, and the margins are 50 by 50. So we'll see the same red rectangle appear here on the screen. And then I could press OK. We don't need to do more here. Now, since both of these are opened from the same PD window, notice how I didn't open these files straight from disk. I opened modules first. We got a PD window. Then I use that PD window file menu to make the new patch. And I used its file menu to open up this patch. Since these guys are sharing the same PD window, being this, the PD console is where I loaded both of these patches from. They both can copy and paste to one another. It's not true if you open two things from disk separately and they each have their own PD console window. They won't communicate that well. So we're going to take over stuff we're going to need. First of all, I'm going to select the array. Just select, hit Control-C, Command-C in Mac. Click over here, hit Control-V, which is Command-V in Mac. So throughout this episode, whenever I say Control as a keyboard shortcut, just realize in Mac it's Command. We're going to take over our record and save buttons, as well as the speed here. We're going to do it in a different way, but we're going to use these same objects. So I Control-C there, Control-V there. We're going to use the open and save functions from this one. So we're going to take those buttons and bring them over here. Now, we're not going to have any granulation going on, so there's no need for a grain size or grain speed. We're not copying those over. We're going to take our audio input over. And you see when I hit Control V, by keeping this basically about the same size as this, it's by default pasting it where it was in the original. So that way, it's kind of convenient because everything is coming over right where it'd be nice to have it. Now, we're going to change this a bit, but we're going to take our loading and our recording on over here. Other stuff we're going to have to make anew. We're going to change our loading. And this is our defaults to get loaded to start. Some of this is fine, but some of this is going to change. I'm going to leave the DSP1 signal in. Getting the sampling rate is good. The playback speed being zeroed out. This just makes this slider start in the 0 position, the middle position. And that's good. We're going to keep that. And then 100. I am going to change this to a different name, though. This is not going to be our grain size. We're going to call this $0 playback underscore. Well, let's not do the underscore. Let's just say playback metro. So we're going to keep some of the same object names, symbol names. Playback speed, receive, and send is sending and receiving from this slider here. And we brought in its 0 function that'll zero it out. Actually, yeah, we probably are going to take over the calculations as well. But the thing that I'm doing differently here is this is going to be different. And we're going to add a little bit of something to this. Oh, wait a minute. Remember, this was supposed to be initial stuff. So, yeah, let's do that. Because actually, this will save us time in the future in making more changes. Sorry about that. Playback metro. Let's call it normal playback metro. Because this is going to be a changeable function. Actually, I'm going to call it normal playback speed. Because really, in this thing, we aren't going to have something really called playback speed, so we might as well reuse that name. Normal playback speed, just like we did over here. So I ended up changing it right back to what it would have been in that loading instance. But trust me, in the future, that'll be a good idea. So I am sorry. You got to follow along with me because I change things mid-flight. It's got to follow along. Now, this sampling rate is going to go out because we may need to have the sampling rate information right from when the patch loads. And we are also going to make this. We're going to say divide by 100. In other words, we're going to take the sampling rate that's coming out of here, divide it by 100, and this will make sense in a moment once we build the playback mechanism. And that thing is going to then be called, we're going to send it right here, $0 playback multiple. Now, this one's called normal playback speed because we're going to have an adjustable playback speed and we want a normal speed to start with and to calculate the adjusted speed off of. But the playback multiple that we're going to make is always going to be this. It's always going to be the sampling rate divided by 100, which gets calculated at the beginning, or if we hit this bang while we're building this thing, we can calculate it. Okay, so we're going to close that. Hit Control S just to save where we're at right here. Now, I realize we do want some calculations. So I'm going to copy calculations over. Control C or Command C. Control V or Command V here. There we go. Now we're going to take away a lot of these calculations because they have to do with our granular synthesizer. Now you see here, we have our sample length. Since we have the same recording mechanism here, that's when, things get recorded. Whatever the length in samples the recording is gets sent out and it comes in here. And we do want that. And in this case, what it was doing was, all right, we were getting the sample length in. Oh, wait a minute. This is playback speed. What am I looking at? Oh, I'm sorry. I got moved over. Sample length is right here. That comes in. That gets, we also receive the sampling rate, divide them by one another, and then what you get is duration in seconds. Okay. Now we're going to change that because we're going to use duration a little bit differently in this. And you'll see why. And then this gives us a normal playback speed in the old version. This is not how we're doing speed in this version. So I'm deleting these here. And what our duration is going to be is it's not going to be in seconds, because this would literally give us the duration in seconds. And what it would give us afterwards is a point and decimal point and then fractions of a second, pretty much going into milliseconds. The way we're going to use duration is going to be a little bit differently. Our sample length will be accurate to the samples, but the duration is something that we're going to round off. It'll just work out better that way. And the way we're going to do it is we're going to round it off to the nearest decisecond, which means tenth of a second. So when the duration comes here in the form of seconds, we're going to multiply it by 10. And then we're going to put it through the integer object. It's int. And what that's going to give us, and we'll put a little number box here so we can kind of see what the number looks like. When that comes out, it's going to basically make it an integer. Let's say the thing is 3.456 seconds long. 3.456 comes in, gets multiplied by 10, so it becomes 34.56. When you make that an integer, it just becomes 34. It just literally cuts off everything beyond the decimal point. So we'll get 34 here. Now what we're going to do is come back and multiply it by 0.1 again. So it'll now be in seconds, but it'll be a point. It would be 34. Oh, let's see. Our example was 3.456 seconds. It becomes 34.56 seconds, becomes an integer where it's 34. And then it gets multiplied by 0.1, to which it becomes 3.4 seconds. It's a way of just getting rid of the extra 5-6 seconds, the extra two places beyond, we just want one digit beyond the decimal point. This is going to help us later in being able to calculate things. And in fact, actually, let me take out that number box. I'm going to put the number box down here below it, so we just see what the final calculation number is going to be. Okay, there we go. And then that gets sent out as the duration. And you know what I'm going to do, just so people don't get confused? This duration, since it's in deciseconds, I'm going to rename it and call it duration DS. First, people won't know what that means, but it's a good indication that it's not duration in seconds. Or actually, no, it is. It is in seconds, but it's a decimal point for the decisecond. All right. Now here we had a sampling rate also coming in to set up what the normal grain speed is. We don't have that in this, so we get rid of that. Over here, we're also going to keep our playback speed, but we're not going to include this stuff. We'll come back to this playback speed and see how the playback speed is really going to work in this. We are going to use this here, playback speed. The normal playback speed comes in. It triggers this 0. Basically, when normal playback speed gets calculated over here in loading, it comes in and triggers the, it makes sure this thing gets zeroed out. Like basically if you recorded something, then you record a second thing. Each time you record, this thing gets zeroed out and it's at normal speed to start. That's all that's really doing. And then here, this is for the yellow bang that we have next to our playback speed. This guy right here, when that comes in, that bang comes in, it bangs a 0 to zero this out. You know, that was our way of getting back to 0 anytime we wanted to easily. So that's our normal playback speed stuff. Now, as we had before, you remember normal playback speed gets calculated right at the beginning of this thing. And in this case, in loading here, we have it set to 100. Let's just double check that. Normal playback speed is 100. There you go. And we'll see how that fits into our mechanism here. All right, so that gets received here. The normal playback speed gets received here. The info from the slider gets received here. You know, here, this slider gets received right here. Goes to Moses, comes out the left side if it's below 0, and that's where it gets inverted. Basically, the range of this slider is -1 to +1, and 0 is in the middle. So if it's below 1, it comes out, if it's below 0, it comes out this side, where swap 1 plus whatever that number is basically going to make it a positive number. And then we add an additional 0.1 to it. I think what I'm going to do in this case is make it 0.01. The whole point is to make it not capable of being 0 in general. So this is kind of like an inversion here. Let's say -1 comes through. This is all the way down. That comes through, goes to swap 1. The -1 comes out this side. +1 comes out this side. 1 plus -1 equals 0. And then we add 0.01 to it. So when this slider is all the way down, we're basically getting close to 0, but not 0 as the actual value. The slider itself, 0, is in the middle, but we're trying to convert that so that as you move this down, like let's say you have a -0.01 come through, which is just below 0. -0.01 will come in here, swap 1. The 1 comes out this side. 1 plus -0.01 equals 0.99. Positive 0.99. Plus 0.1 makes it a 1, which in these terms here with the multiplier means you're multiplying by 1 times the normal playback rate, so you're getting the normal playback rate. So as long as you're close to 0 or on 0, you're going to get the normal playback rate. When you move down, you're going to get fractions of it. Like I said before, going all the way down to 0.01, basically slowing it down. Now, normal playback rate in this case is going to be a range of 0 to 100, but this calculation makes sure it's like 0.01 up to 100. And then if we go with this slider above 0, over here, that comes out the right side. It gets multiplied times 3. So let's say it's at 0.5, halfway up above 0, right about here. Okay, then what we get, 0.5 gets multiplied by 3, that's 1.5. Plus 1, that's 2.5 times whatever the normal playback speed is. To start, it is 100, and it stays that way. So here it gets multiplied by 2.5. That would be 2,500. And what that is going to do in this case is actually slow things down. What we basically have here is this. I just thought of that because now that this normal playback speed is going in a range of 0 to 100, comes out this side and what comes out this side are really going to be the opposite. So it would basically end up being, as you move this slider down, it's going to be going faster. As you move it up, it's going to be slower. There's a simple way of reversing that. We can go into its properties and say that it's +1 up to -1. So that way, when you move it to the right, it'll speed up. When you move it to the left, it'll slow down because it's basically inverting what is being sent to our calculations. Okay, so at least right now, our recording functions are going to be exactly the same. It's even going to record into the audio folder that we already have, that we made, and been keeping with us. I am going to close the granulator patch now. Did I change things in it? I guess I did. So I'll say, yeah, save. And we're going to focus on our new tape looper patch. All right. So, did I copy this twice? It's bizarre. Okay. Got rid of the extra one. All right. So, now we're going to have to make our PD playback here, and this is where it's all going to come together. PD playback, and this is the place where we're going to get information about how this thing's going to play back. Now this I'm going to turn into a big window because this is going to need space. I'm going to try to do this in a way that it doesn't get cluttered. Now, what we get coming in are 2 bits of information. Receive $0 play _send. That's coming from our play button. That's its send symbol. So when the play toggle gets checked off, a 1 comes through. When you uncheck it, a 0 comes through. And so just like before, I'm going to put a select under it, SEL 1 0. And I'm going to make this real simple here. I'm going to make sends. This is what I eventually did with the other one. But at first it got a little cluttered. Just to eliminate some clutter, I'm going to say when play comes, it's going to send a new signal just called $0 play start. Okay? This is the way select works. You put in how many things you want in order. The first one that you put in as a creation argument will come out the leftmost outlet. So one will do this. And when that toggle gets unchecked, it becomes a 0, it'll come out the middle one. The third one is for none of the above. Send $0, play, stop. And of course, in this case, we can't get a none of the above because the toggle only sends out 1s and 0s. Okay, so that will be our play stop signal. All right, and our play start signal. Okay, so now how is this playback going to work? Well, fundamentally at the bottom, we are going to be putting a tab read for tilde $0 waveform. We're going to read the table once again. And now what is the name of our audio outlets here? Because it eventually goes to this. Receive $0 audio out. So we got to send it to that. Send $0 underscore audio. Is it another underscore? Yeah, audio out. Okay, and in between this, I want the ability to mute this and turn it on and off. So we want a star tilde for the audio signal coming out of tab read and going into the send, which sends to our audio output or audio out that goes to the outlet, and then the signal goes outside of this module. Oh, remember, whenever you're sending audio signal, the sends and receives need to be tilde objects, S tilde. Alrighty. I'm going to move this. The thing is, I know this is going to get tall if I'm going to leave enough space for people to see what's going on. So I'm going to move this to the bottom. This could be right next to it. And if I don't want my patch cables to look all wonky and stuff or webby, I got to do this. Now, this is where we have the ability to mute things. And what I'll do is I'll use sends and stuff like that to tell it when to mute. So I'm going to do this. Make a receive called $0 mute on. I'm going to leave a little space here because I'm going to do something a little extra special because I know that we're going to need this. Mute on, and mute on is going to send a 0. And rather than putting this 0 straight into here, I'm going to put it through a line tilde object. We've done this before, but I'll explain it again. We're going to pack this 0. The 0 is represented by F, meaning float. And whatever comes in through the left inlet will take the place of F and basically come out as a 2-part message, because we're sending it with 100, which is the time in milliseconds that it's supposed to take to reach this number. I need to put the line tilde in. Hold on a second here. Let's move this up. Line tilde. All right, so there we go. So when the mute comes, it takes 100 milliseconds for it to go to 0. That way it doesn't snap off suddenly. That's something I should probably even add to the other module, the granulator. Now, one thing I am going to do here, there's space here. I want to make sure there's space here because I know something I'm going to do in the future, not this episode, but in the future, we're going to be able to adjust some of these things. Or actually, you know what? 100 milliseconds is pretty. Let's make it 50. 50 is enough that it'll be smooth, no problem. Okay. And then we're going to do duplicate. I selected and I hit Control D to duplicate. And in this one, it's going to be the partner. It's going to be 1 to turn this on. And we'll call that mute off. And then hook that up here. So when I send signals to either mute on or mute off, it could just be a bang. They're just going to put a 0 or a 1 in to mute or turn off the mute. That's all we did right there. All right, good. So that our signal can be muted because we're going to want it in this. Now, this is something that is going to have some building and building onto each week. And I'm trying to build it in such a way that later it won't be a bunch of things to change. Here, I'm trying to just move this over. Okay. Now, tab read. What's going to tell tab read what and how to do this stuff? Actually, tab read can move down here because we're not going to put other patching in below it. All right. Well, in the last instrument that we made, or the one in the first four episodes of the series 2, it was basically using a phaser to go from 0 to 1 at the audio rate. And basically, we used the calculations based on the sampling rate and what the length of the sample was to make the frequency input of that phaser go slow enough that it would play back in real time, but then we allowed for speeding it up and slowing it down later. And we had to multiply its output by what the total sample length was so it would go from the beginning to the end, rather than just 0 to 1. In this case, we're going to use a counter. Not the counter object, but the object metro. And I'm going to put a creation argument in here, 100. That's our normal playback speed. That is the normal starting speed. We're going to allow for the playback speed to change, but we'll put 100 in to start. And that'll help me explain this so you can see how this mechanism is going to work. Metro. We're going to make a float box here. And Metro is going to be hooked up to its left inlet. I'm going to leave a little bit of space here because we're going to want other things to access this float box too. And then we're going to make a plus 0.1 adder. Now, you notice how we've been using number 100 for playback speed, or in this case, really normal playback speed. That's the original playback speed. That 100 represents milliseconds, just like it does here in Metro. Metro is going to bang every 100 milliseconds, which is 10 times per second. So 10 times per second, the number that comes out here is going to be added to 0.1 if we connect this up to the left inlet here. So we'll get 0.1 added to, like the first number is 0, it becomes 0.1. And then it comes out of here, gets stored in here as 0.1 and gets banged again, and another 0.1 gets added, and another, and another, and another. Now, before I hook this up over to here, we want some other possibilities down here. Or actually, maybe I'll do this for now. I'll hook this up, and then later I'm going to show you what we're going to put in here to be able to deal with some things. Alrighty. Next. Now, this outlet could be this one, or it could be this one. Let's go with this one here. We're going to take this outlet, and we're going to put a number box here so we can see what's coming out. And let's make the number box bigger. Let's give it about 12 digits. That'll be plenty. All right. So that's where we're going to get these numbers coming out. Now, how do you start this? Well, Metro starts with a start. Sorry, we need to make a message box. A start message. Or you know what? It starts with a bang, believe it or not. Bang. You can do a bang like that, just a message that says bang. And then it's going to have a stop message for stopping it. Yeah, I keep forgetting Metro has those guys. There we go for starting and stopping it. I'm moving it to the side here because I have a feeling there's going to be other junk here. All right, so that's for example, we could start it right now. We could go bang, and you'll see this 0 start counting up by 0.1, 2, 3, 4. But since that's every 100 milliseconds, that's 10 per second. So you'll see the number before the decimal point pretty much go up a lot in line with seconds. But you'll see the dot, tenth of a second number right on the other side of the decimal point, kind of like the countdown for the last shot in the basketball game. 2, 3, 4. There you go. Stop. So that's what we're getting here. Now, the first time we play this, we want to put a 0 in. And what this 0 is going to do is it's going to go into the left inlet of float because it's meant to go all the way straight through. See, if I go into run mode and hit this 0, it zeroes it out right away. It doesn't get stored in the right inlet like this number does until the Metro bang comes through and pushes it through. This one we want to go through right away, like when we really want to zero it out. And in fact, I'm going to put a receive for this. Receive. Actually, no. We're going to... we'll put in some receives and stuff later. I'm jumping ahead of myself. Now let's get to the rest of the explanation of how this plays back. Okay. So it counts up here. This eventually, we're going to have some... Oh, no, I didn't mean that. Cancel. Save. Okay. We're going to put other patching in here, but for now, let's just make an object, and we're going to say times and I'm going to put in for the time being 480. Because over here in loading, you see how we take our sampling rate and we send it out, but we also we divide it by 100 and we get playback multiple. And that's going to be this guy right here. This is our playback multiple. But just like anything else, having a default in doesn't hurt anything. I'm just saying 480. But even if you have a different sampling rate, like your 44-100, 441 will get shot in here pretty much right away as soon as the patch opens. I'm just putting the 480 in just so the thing looks longer, I guess. Actually, no, we don't need to put it on at all, because you know what? When that load bang goes off, this number gets in. When the patch opens, a number will get in there. So we'll make it $0 play back multiple. Of course, that didn't work because it needs to be a receive. So we're receiving playback multiple from that one there in the initial load bang in PD loading. So in this case, you know, since I'm at 48,000 samples per second, basically right from the beginning, it's going to be 48,000 divided by 100 is 480. And that would be our multiple to start and stay pretty much. So basically these numbers here are getting multiplied by playback multiple, and we'll see them come out here in a number box. We'll pop a number box in here, make it also 12 in length. So when you're multiplying by 480, basically these numbers that are 1 point whatever are going to be, well, wait a minute, they are in seconds. And there is deciseconds, you know, there is the point number there. You know what? I don't need to make them playback multiple. It's being sent in seconds, so receive sample rate. We can get rid of that. I am so sorry. Now we're going to pull this down because we're going to have other stuff that's going to come in here, maybe not this week, but eventually, for when we get to the end of the thing. Well, we'll put some of that in this week so it can tell when it gets to the end. But anyway, what happens here is then this number gets converted into pack F. And then how many times per second is this being banged? How many chunks of material are coming out? 10 times per second. So we need to make the pack F100 here. And this, just like Metro up here, is going to receive playback speed. $ receive $0 underscore playback speed. Because our playback speed is how many times per second Metro bangs. But that is also, I'm going to copy that. Well, no, duplicate it and drag it down. Also, that needs to be here because this is saying, right, we're converting this into an audio signal and it's doing it over a line being drawn in audio signal from one number to the next. So we basically are going to put a line tilde right here after this pack F100. So at the audio rate, it's going from sample to sample at the sampling rate. But 100 milliseconds is what we need because that's how many times per second we're getting a new number. You see what I mean? Every new number is almost like a counter going to the next sample. And all this goes to tab read. So basically, when it goes from 0 to 0.1, since that's 100 milliseconds worth of time, this line object is going to be putting out the number 0 to 1 over the sampling rate, the audio rate, during 100 milliseconds of time. So it's just a straight stream of audio rate sample numbers at the sampling rate. But we're putting in the playback speed thing so that we can adjust the speed later. Okay, now we want to be able to start and stop this. So For starting, we're going to put a receive here. If you want to start at the beginning, I think we're going to put in a button to rewind to the beginning. $0, play start. Now the reason why I'm doing a send and receive right here when I could connect up a patch cable is because play start is going to be connected to other things. If you want it to always start from the beginning of the sample when you press play, you could hook it up to here. But I think I'm going to hook up a rewind mechanism, a rewind bang, so we can rewind to the beginning. And you have to hit that, otherwise it picks up where it left off, just like a real tape player. Okay? And now we're going to go down here because we also do want to say that whenever we start, actually I'm going to put this to the side. We save $0 play start. Whenever that happens, we're going to immediately send it out to $0 mute off, which means sound gets turned on. We may, and you'll see, eventually we're going to add functionality where we're going to put some delays and things in here to deal with a certain effect that we get when we do this. But I'm going to let it happen so we can see what it is. And then let's just duplicate this and make this play stop. We'll mute on. So that turns on the mute when we stop playing. Okay. Now, also play stop should hit this stop message here. Receive $0 play stop. Now this is where you can also, if you wanted to, when it stopped, you could have it reset to 0 automatically. But I don't want to do that. I'm going to put in a rewind here. In fact, we're going to make that bang now for rewinding. Let's call this receive $0 rewind send. The reason why I put that label send there is because this is going to be a graphic object. And you know all our graphics objects, the toggles, the sliders, they have two symbols. One's a send, one's a receive. So I always put that in there. Okay, so let's make our rewind bang. And then we should be able to test this out. I'm not sure if I'm forgetting anything just yet. Right now, this would play, and then it would keep playing even when the table runs out. But we want to test it, and then we'll fix that later. Let's put play here. In order to get a little more space, I'm going to change this thing's name from record to rec. So we don't have the extra text hanging out over the edge there. And what we want to do, we'll just take like a bang like this, duplicate it and change it. This is going to be rewind. I don't know, let's make it orange or something. We're going to call it REW as an abbreviation for rewind. And its send symbol is going to be $0 rewind send. And this is $0 rewind recv in case we need to send something to it. Okay, there we go. Now, let's test it out our recording mechanism's the same as before, so it should work. There should be no problem recording to this table, but let's see how our playback works. And of course it didn't. Do we have any errors here? This table is called $0 waveform. Here's recording. Well, I know one thing. We don't have audio coming in. Okay. This is what I got to do. I got to put this in our other patch. So let me close all this. I saved it. Now, week to week, our modules will change. The modules patch will change, but I want everything there so that coming up in the future, we can hook up multiple modules together. But for right now, I am going to, as we're working on just getting this module working right, I am going to change modules.pd to just have this module that we're working on right now. So let's delete these guys here. They all work fine. We don't need them. Now, what was the name of it on disk? It was tape _looper _mono tilde. And you don't need to type the .pd. There we go. So the left, or input 1 from our sound cards going into here. And then the output is going into DAC, but we want it to come out both sides. So let's just, for this week, keep our modules.pd file to just this module. I'm going to make it look nicer. Okay. See, the reason why inside the module it wasn't working is because modules.pd wasn't open, so this ADC wasn't present to supply audio signal to this patch. So we were probably recording a silent audio file. Hello. This time, hopefully, we do get sound, and it should work properly. There we go. Now let's press play. Now, if I stop there and press play again, it continues where I left off. I have to hit rewind to go to the beginning. Now, you hear that? When I hit rewind, it went click. That was because sound was still on. Now, you may like that, so you may leave things like that in. But let's see here. You see how that keeps going? Now, we got to find out why rewind. Because when I stop here, I should be able to hit rewind. And it shouldn't do that because once playback stops, here we can open up playback now. Now, everything we do here, we can still test. Audio will run. Here, when the toggle gets turned off, it should send $0 play stop. And play stop is hooked up to mute on. Which is why this should be muting. Here's mute on. That sends a 0 in. And that should be turning this off so that we don't hear the, the sound of it, basically audio being shot backwards over 100 milliseconds back to 0. We don't want to hear that. Let me see here. Is everything typed properly? Receive $0 MUTEON. MUTON. Receive $0, play, stop. Send $0, play, stop. Let me test something here. Sorry if I'm going off screen a bit, but I need to be able to see both of these here. I rewound to the beginning. I'm going to press play. Hello. This time, hopefully, we do get sound, and it should work properly. All right. I heard sound go off there. Now let me hit rewind up here. Hello. This time, hopefully, play was still going. So when I hit this, it did mute sound. Now, of course, it's a 0 going straight in. $0. Let me just make sure. My vision ain't great. I want to make sure that I am typing this properly. Receive $0 underscore mute on. This is how you debug, folks. Over a little bit. $0 mute on. And that's being triggered by $0 play stop. Make sure I do have an underscore in there. Okay. And over here, we're sending $0 underscore PLAYSTOP. The rewind comes here, where it's sending a 0 in to put that back to 0. But the thing is, here, let's just double duty the job here. I shouldn't have to do this because I created an object and it made an extra object here. Shouldn't have to do this, but just to double, proof it, we're going to receive the $0, rewind, send right here, and we're going to make that also send $0 mute on. And mute on means the mute is on, the 0 is sent. Because I don't know, with this closed, with this zeroed out from this 0 right here, with this zeroed out, we shouldn't hear anything coming out, even though tab read is going to 0. All right. Let's see. This is our modules.pd file. I can minimize this. It won't let me. What's going on here? Whenever I get that message, I like to cancel. Okay. Let's put you down. We're working with you. Okay, let's try now. I am going to record a new thing because I want to make sure it's long enough that I can kind of go around and do things and check things and see what's working and what's not. Because I want to make sure it's long enough. I am going to record a new thing because I want to make sure. I am going to record a new thing because I want to make sure it's long enough that I can kind of go around and do things and check things and see what's working and what's not. All right. And you see there, it was still playing, but at the end, it gets to the end and it just keeps going on. I think I might know, rewind I think I know what we got to do in both these cases. And I'll show you what it is right here. Let me get this whole thing back on screen. I'm sorry. Before that part, I was sorry I was off screen. But this is what I put here. And I'm going to leave it. Actually, no, I'm not going to keep it. So what I did off screen, that shouldn't be necessary. This is probably what needs to be necessary. These mutes happen over 50 milliseconds. So probably what I need to do here is delay any of these stops for times where we're going to be. Let's delay 50 milliseconds. When we hit rewind, we're going to delay 50 milliseconds. See if that does it. Because literally, right now, all right, I have things muted. I should not hear this going to the beginning, but I do. Why? All right, I'm going to pause, folks, and try and figure out why this is happening. Okay, I'm back. It is a very strange thing. I got it working, but I don't think I should have had to do this. What I did is down here, I just took out the line tildes and the pack F50 messages. But I've been using those for like years now. There's no reason why that shouldn't slope down to 0, slope to 1, alternately. I don't know, but this is working out fine enough. So I took those out and I basically have the message box just going straight into here. All right, that's all that's changed there. So let me see here. You can play. I am going to record a new thing. If you want to hear it while playing, you can rewind. I am going to record a new thing because I am going to record a new thing because glitch effect when you do that. But when you stop playing, rewind is silent. So it is now shutting off the sound. Somehow going through the pack F50 and line tilde, it was not zeroing out. And I don't know why. I've used those for ages. I don't know. I don't know, folks. Well, anyway, we're working now. Now, the last thing we want to do is be able to have this thing stop at the end. And I think what we're going to do is have an optional loop function here. We're going to basically put another toggle down. So that it can loop or just stop. This will be the last function we put in today. So we want to use a toggle. Bangs, remember, are to send a signal. Toggles are to say on or off by expressing a 1 or a 0. So here we can say loop on or off, whether it's a 1 or a 0. $0 underscore loop underscore send. $0 underscore loop underscore receive. There we go. Alrighty, so that is how we're going to send the signal. Now let's actually patch it in. Okay, so first of all, we have to put something in that detects we're at an end. Now that we got extra space here, I'm just going to move these down. All right, there we go. And here is the perfect spot to do. No, it isn't. This is where it gets multiplied by the sampling rate. We want to do it in duration, like in seconds. We're still in seconds at this point. So we can use our old friend Moses. And Moses will receive, through its right inlet, $0 underscore duration, which gets calculated in the PD calculations subpatch that I was showing you earlier. It's expressed in seconds, but it will have one digit beyond the decimal point. So that comes into the right inlet, and that tells Moses if it's this number that comes in, the duration or above, come out the right outlet. Otherwise, come out the left. Now, what comes out these outlets? Well, the stream of numbers. So if it hasn't gotten there yet, it hasn't gotten to the end, we want it to keep going down here. We don't want it to stop its flow. Now, if it has reached the end, then we want to have some options here coming out of this right outlet here. Loop on, let's see here, $0 underscore, now we got to receive R, $0 underscore loop underscore receive. This is what we receive from the toggle. And then what we got to do is say, all right, if we get a 1, that means loops on and we go back to the beginning. If we get a 2, if we get a 0, then loops off. So what I'm going to do here is do this. I'm going to make a select 0, 1. You could do it in any order just as long as you know if 0 comes in, if loops off, this is where the stuff will come out. And what do we want to have happen? Well, if the loop is off, we want it to stop at the end. So we can trigger, because what's coming out is a float, a number. Trigger, bang. Actually, 2 bangs. And what's going to happen here, let's move this up here, is if, loop is off, we want it to stop and then rewind. So what we're going to do is send the signal play stop, which will also mute, and then send rewind. We want rewind to be the second one sent. Send, play, stop. I forgot the $0. And the right outlet happens first, just before the rightmost outlets go first, and then they go right to left in order. But real quickly, of course, but nevertheless, the one is first. Actually, we could send it to the receive, which will bang the bang on the outside of the patch, and it'll look like the button was pressed, but that will also go out at send, which will go here to actually put us back at the beginning. Okay, so that's what happens now. The thing is, we only want this to happen when it gets to the end. Uh, so this is how we're going to do it. Okay, right here, we're going to, I need to put a float box in the middle here. Whenever this gets switched, it will store the 1 or the 0. Whether the loop is on or off, it'll store it because it's connected to the right inlet of the float. But it will only determine if this is the case, like is loop on or not, when it gets to this point. When Moses bangs out here, and I'm going to put a trigger bang here, and it's going to go to here. Now, the way you could loop this is put a mod with the duration of the thing on it, the duration of the whole time, that you receive from duration. Right here. We can have a mod there where basically it'll cycle these numbers back around. You just feed it right back up into here, into this float, and it'll cycle the numbers around and go from 0 to whatever the duration is. And so it'll go in a circle. But every time it gets to the end, you're going to hear the tape rewind. You're going to hear, you may not want that. I mean, you could always cue it by tapping the rewind button while playing back if you want it. And we are going to add some functionality later where we can scrub around. But let's say we want to loop, but not hear it rewind like a tape player. Well, that's where this one section comes in, which comes out the middle outlet here. So the 1, this means the loop is on. And basically, we want a few events to happen. We're going to trigger the following. First thing, we want to mute on, then rewind, and then start playing again. Now I put a delay 50 on this mute. I'm taking that out. That was just before I thought that maybe it wasn't muting fast enough or something. I mean, really, the rewind shouldn't have to mute. When you stop, we shouldn't have heard the rewind anymore. Somehow the PAC F50 going into line tilde wasn't doing it. It just wasn't. I don't know why. Maybe I should go back to earlier versions of PD Vanilla. Those who are listening, if you've put that patching in and it was working fine for you, let me know. Maybe there's still some bugs in this version. I think I am in the most recent version of PD Vanilla. So it may not be technically a stable release. Although that's pretty fundamental stuff that's been in PD for a long time. So I don't know why that would be affected. But in any case, we're working around it. So do let me know in the comment section and so forth. All right, so because first we want to mute things. Send $0 underscore. Well, we could say play stop. Play stop will mute, and play stop will stop playing. That happens first. Next, we want to rewind. So we send $0 underscore rewind underscore recv. We're sending it to the receive, so that way the the graphical object, the bang itself, will blink as it rewinds. So it'll be like as if we had pressed it, even though we didn't. It's nice to have visual cues like that. I'm going to move this stuff down because we still have another one to do. Now, the thing that we're going to have to do is that rewind is going to be the same amount of time going. I mean, it'll go to 0, but because duration is down here, or not duration, the playback speed is down here, 100 milliseconds to start, or whatever it is. During that playback speed, that's how long we got to wait before we start playing again. Otherwise, we'll still hear some of that rewind sound. Send $0 underscore play start, but we need to delay it by, we'll put 100 in as a default, but it's going to receive right here, and it's right inlet receive $0 underscore playback speed, because whatever that playback speed, that is how quickly it goes from one, index to another, basically, in this counter. And so when it's rewinding, that's how long it takes to rewind. It's really 1/10 of a second. So while it's doing that, wait before you start playing. This will sound pretty continuous to us because 1/10 of a second is a short amount of time for the listening human being. Now let me see here. I want to clear this up a little. Maybe I should just drag these things to the right. So there we go. Put you over here. And I can move this down to make sure it's obvious that that patch cable is coming out of the middle, the second outlet of select, because it's the second option in a row. There's always an extra option other than the creation arguments you give. That's none of the above. Okay, let's test it out. Gonna save it here. Okay, we might as well record one more recording for this beautiful, hopefully, end of this episode debugging. Let's see if this works. Okay, we might as well record one more recording for this beautiful. Okay, we might. So you hear the rewind when you're still playing, but when you get to the end, oh, hold on a second. I'm going to make one more adjustment. Another thing that would be cool is if we send it to play receive. When we stop and start, here I'm saying play stop. Oh, we do want that because that is here, but this is what we can add to here. Anytime play start and play stop happen, it's going to work like this. This is so the user gets feedback on the outside, some visual feedback. Anytime it automatically, because the only time play start and play stop happen, other than when the person actually clicks on it, is when it's happening automatically inside here. Although, hold on. This is not the way to do it. No, not the way to do it. Not the way to do it. Because these things also go off when you do click on it. And so we want these things to just stay the way they are. This is just for auto rewinding. Okay, so already here, if loop's on, nothing needs to be shown, right? Play, stop. Well, yeah, except for the rewind button being hit. That's when it's off. That's when it's off. Sorry. When it's on, it's going to send it to the graphic object instead. And what we're going to send to $0 play underscore receive is a 0 message. So this will go to the toggle on the outside that gets viewed, and it will turn off the toggle. So the user will actually see the play button turn off because it's not playing. But since that toggle gets turned off, it still performs its function of queuing up play stop and play start here, triggering this to happen. And basically everything's going to function the way it should. It's just we're giving the user a visual. Here, rewind, receive. Here, instead of sending it just to play stop, we've got to, and we can't just send a bang. Remember, these are toggles. We got to send a 1 to play RECV. So that way we'll see the play button get toggled on again, and all the other functions will happen. Okay, let's do that. Sorry about that, but might as well go the extra mile. Okay, let's see here. Might as well record one more recording for this beautiful, hopefully, end of this episode debugging. Let's see if this works. It did not. All right. Well, one thing we should do is, since we put all these objects in, is go up here to the load bang and start things over. I'm going to basically put this stuff through, because some of those duration objects, those duration receives, probably don't have duration in them. They're zeros because we only just put them in and the information didn't get sent. Okay, let's just record one last time. Okay, let's just record one last time. Well, the play button did go back on. What we're going to have to do, here, I'm going to shrink this down because I need to be able to see both of these on screen at the same time. I want to see what's happening with those buttons and be able to trigger those buttons, and at the same time see here. Okay, so the idea is we're going to see what happens here. We're going to be seeing the numbers come out here. Moses should have received its duration. Let's double check that it did. Let's go to calculations. Sample length divided by sample rate. We get 3.2. Times 0.1, 3.2. See, this is 3.212 up here. And this math makes it 3.2. The reason is because I know Moses would have more trouble seeing all those other milliseconds go by. So we want it just to be, 1 digit beyond the decimal point, tenths of a second. So Moses can see 3.2. I don't think Moses is just an integer. it may be just an integer. Well, there's one way to test that. Let's let our duration be in deciseconds instead of seconds. Maybe Moses doesn't read that. So how do we calculate that from the beginning? We start over again. This is the debugging process. This is what everyone should do at the end of building their patches. This is the debugging process. This is what everyone should do at the end of building their patches. I see it did click it back on, but nothing's happening. So let's go back here to playback. Look at this here. Yeah, it never got sent back to 0 is basically what happened. But when this rewind is sent, it should go to 0. Let's see here. Send $0 rewind receive. Oh, shoot. You know what? Well, we have loop off. That's one thing. Let's turn loop on and see if it loops. This is the debugging process. This is what everyone should do at the end of building their patches. Now, that didn't work either. We should have looped around to the beginning at this point. So I'm going to have to look over here as I do these things. Let's rewind. This is the debugging process. This is what everyone should do at the end of building their patches. Yeah, this number's still going. I'm going to have to pause so I don't take a lot of your time in trying to work this out. I'll be right back. Okay. I am back again, and I figured it out. And now I'm going to take you through what I needed to change and change back. First of all, under PD calculations, when I was trying to figure things out, remember I took out this, and basically was sending the duration in deciseconds. Well, the thing is, the counter that's sending numbers through for Moses to detect when it gets to the end isn't in deciseconds, so this was just a wrong attempt at trying to fix it, and it didn't do it. So I put it back the way it was by multiplying by 0.1. Basically, the whole thing is this is maintaining things in seconds, but it does the multiplication and uses the integer just to get rid of the extra numbers beyond 1 decimal place. We just want tenths of a second. And so this is what does that. And we need that. That wasn't the problem. I was trying to find the problem, and I tried that, and it did not work out. So that had to go back the way it was. And then in playback, sure, we're still on screen here. I had to change these things back. Remember, I wanted things on the outside to display, like when the play, like here, when it stops, I wanted the not only play stop, I really wanted the play button to turn off. You see right now play is stopped, but it's still showing that it's on. But I tried sending it to its receive, and that didn't work because all that did was the object received it, but it didn't send it back out its output to actually do it. So what we need to do in that case is just have, just to make it look a little cleaner here, I am going to put an extra bang in where we want it to go to play stop. So you got to change this back to, instead of a 0 message going to play underscore receive, it's got to be send this bang to $0 underscore play stop, which is up here in the patching to stop playback. It'll also trigger it to mute. And then what we want to happen in addition to that is for it to send to the receive outside play RECV, but we need to send it a 0. So we need to get a little more real estate here. Alrighty. Please. And move you out a little bit further. I like the patching to be clear so people can look at it and see what's going on. Not have it be too messy. All right, that should give us enough room here. So now this, remember, needs a 0 message. It's basically telling the toggle to go off. So it's almost like you have to do both from in here, because when you send to play receive, it doesn't send this 0 right back out again. That would create a loop. So it basically receives the 0 and and basically turns off its display. That's all it can do from a receiving perspective, but it doesn't send it right back out again. So there we go. That takes care of that. Now over here, of course, we had it sending to play to stop. Basically here, I need to put in 2 extra bangs to do all things. Bang, bang. So yeah, we want it to send message box a 0 message to send $0 underscore play underscore receive. So that way the play will get zeroed out visually. And we need to send a bang to play stop, which will stop playback and mute while we rewind. Now this gets sent to rewind send. Oh no. Yeah, let's put another bang on here, because it would be nice. It would be nice, I know. Here we are doing extra things again. It would be nice if the rewind button itself did blink when it's automatically being pressed. Because this is when loop's on, and what you expect when you're looking at it from the outside is to see that it stops, rewinds, and loops, plays again. And you want to see that visually happening with the buttons for it to make sense. Otherwise, you see that what the button is showing has nothing to do with the state of things. Like right now, since the checkbox is on, the toggle's on for play even though it's stopped. So here we're going to send $0 rewind. Let's make sure to type it right. Underscore receive. And what that means is I forgot the message. we need to send it a 0. Or no, we don't. Remember, the rewind is a bang. It's not in a state of 0 or 1. It just bangs. So what we want to do is just have it flash. You know, it'll flash like it's been banged. That indicates the cue of a rewind. And then here's the actual rewind being sent internally in the patching, where this 0 goes through and rewinds it. Then over here, yeah, I'm off here with the they're supposed to be in order how I want them to happen. So basically, there we go. This is where the rewind happens. And we have 2 spare bangs left, which we need. One is to do this, to take the playback speed, which is going into delay, but at the bang this delay, so it's delayed by the playback speed before it actually starts up playing again. And then when it starts up playing again, it's good for it also to look like it's checked off and it's playing. So we need to make a 1 message and then send $0 underscore play underscore receive. So that way the toggle box will be checked and it'll look like we are playing. Okay. Now let's test it out. I did look at it before and I saw that it was working again. So basically internally, when this number gets up to the number coming into Moses, the received duration, I put like a creation argument in here. I put a 10 in to begin with just to see if it would loop at 10, and it wasn't working because the counter was different than the duration. That's why the durations had to go back to the way they are. So the duration's in seconds with a point and tenth of a second. Okay, so I had to go back to that. And so this whole initial value for Moses doesn't really matter, so I'm going to take it out. Basically, I'm putting things back to the way they were before I paused the video and fixed things. Here. The other stuff is the way it is now. There we go. And if I really want to be analytic about this, move you guys over a bit. Move you over. Come on. Select you. All right. Now let's see. Yeah. See, you would have to uncheck it as off, but it still won't send off until you do it again. So now this should work. I'm going to keep loop off. What it should happen is it should just stop when it gets to the end. I am going to record this again just to test. I am going to record this again just to test. All right. Now if I press play again, it should play from the beginning. I am going to record this again just to test, because we have it rewind at the end, and you see it turned off the checkbox, so we know that it stopped playing. So we could turn on loop here. Hopefully it'll loop. I am going to record this again just to test. And it did not. Okay, still one more thing. Let's make sure here of what our symbols are for loop. $0 _ send. We don't even use this receive. Okay. Now, the thing is, we saw, at least when we had the loop off, it did stop and rewind automatically. So the loop off functions here did work. So Moses is detecting things, and it went back to 0, you see? I didn't hit rewind. It went back to 0 automatically. But it was supposed to go over here, where it was supposed to hit 0 as far as play, receive, turn that off, do the actual stop of playback, then rewind, receive. That rewinds it. And we did get rewound. It's at the beginning again. I saw a 0 there. And then the rewind send. I don't know if I saw it flash or not. So that'll be something to look for. But here we're receiving $0 playback speed. I wonder if this ever got sent playback speed. Well, whether it did or not, that would mean like no delay, but it would still come out, I think. $0 play start. And a 1 going to $0 play receive. So this stuff is correct. Receive $0 loop send. Oh my goodness. I'm glad to see this worked. It probably didn't, but I didn't notice it or something. Because it's the loop toggle is sending to here. It's sending its 1 or its 0 to here. So we need to be receiving from its send. We can't receive from its receive. Okay. Let's start all over again with the recordings. Make sure it gets sent. Start all over again with the recordings. Start all over again with the recordings. Start all over again with the recordings. Start all. Okay, we're hearing this because that delay is not happening. Playback speed. Well, I do this, it definitely got sent. Probably if we go back to the beginning there. Let's see. All over again with the recordings. Start 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 all over again with the recordings. But at least it does stop. So when you take loop off, it stops. It's working. It's just we're hearing that rewind sound in between. Well, there's one way to check this. $0 playback speed. Well, we could test our playback speed, see if it's actually happening. Start all over again with the recordings. Oh, loop it. Over again with the recordings. Start all 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 over. Okay. Let's try this. Let's try this. Right here is where it's at. this is where it's supposed to delay. And actually, it should delay for both. I'm going to use the same bang for both. Yeah, let's just clean this up. Darn it, I hate doing this. Repatching things over and over again and trying to line them up. I know it's annoying. Here, I'm just going to connect them quick. At the end of the day, I do want good-looking patches, so I'll straighten this out later, but we're going to have these things share the same bang because they're both going to be delayed. Now, this is supposed to receive $0 playback speed. How about we multiply that by 2? But let's also make sure that we see it before it goes into delay so that we know it's actually happening. I mean, it seems to be spelled correctly, but, you know, this would be an indication to check the send that it's coming from to make sure it's correct. Oh, stop it, will you? All right, so just making this look nice. All right, and then down here, send. We'll divide this up into 2 bangs. You could literally just put it as 2 cables to each one, but I like to put triggers in just so I can see the routing better. You know, it just actually looks nicer, in my opinion, than to see a spray of cables going to multiple locations. I mean, this is just 2. This isn't bad, but a lot of patches where I see all these cobwebs. It's like, that's annoying. All right. So now, let's see here. Let's go here to the beginning where we're going to load. All right. And we're going to record one more time. I hope, like that. Now let me look here in playback. Did we get a delay time here? Ooh. Playback speed times 2. Should not be 10000. 10000. That's 10,000. That doesn't make a bit of sense. Well, I have it connected to both outlets there, inlets there. That would do it. Okay, let's go. We got to do that again just to make sure getting the right values there, because that's the thing we got to fix. I think it's the last thing we got to fix. The playback speed seems to be working, although its range is a little weird. Oh no, we have to change the lower half of its range. But that'll be quick. We'll fix that with this slider. Like the slow part of its range are numbers that just don't work for it. Or I don't know. We'll have to see. Okay, so what's going on here? I just can't think anymore. I've been patching hard tonight. We just record again. Stops, good. Now when I put on loop, not going back to the beginning. Why the hell not? Oh man, sorry, I'm just really... Oh, it did it. The delay was just really long. Yeah, 1,000. What is playback speed? We got to look at what playback speed is in calculations. One, zero, zero. It's 100. Why is it still 1,000 over there? Okay, let's just hit that. $100 times 2 is 200, not 1,000. $0 playback. Is this typed right? PD's been doing weird things. Here, when I hit this button, that resets it. In calculations, playback speed, oh, that's, yeah. Playback speed is 100. And that should have just gotten sent out. Or when I move this, definitely sent out. Did I stop playing? Yeah, I must have hit it. Why is it at 1,000? Let's put it at 100 manually there. No. Hold on. All right. All right, we got to check this out one more time. The hell is that? All right, folks. You know what? I've been taking some... Okay, I hope I am recording again, because this threw me out last time. It was some job, but I got it working. As you can see now, it's working, and I'll show you the patching on how I did this. All right, so that's when you play and it just stops automatically. Starts right from the beginning as supposed to. Now the loop. All right, so we got it looping. I'm going to show you the patching on how, and then I'm going to show you the fixes I made on the playback speed, because that wasn't working right. All right, first of all, where we kind of left off was in calculations. No, we're going to come to that. I'm sorry. Playback. Here's what I did in playback. First of all, down here, I switched the order here where basically the one message going to play receive goes to the right of the actual play start command. But they're both on the delay that is now not 2 times the playback speed, but just the regular playback speed coming in to delay and triggers 2 bangs, one to turn on to make it look like the play button's on, and one to actually start playing again. Those are the only fixes I made here, except for one more thing, and that's here. This 0 message is, actually, I'm going to try taking it out of here. But we just have the 0 message now going to the right inlet of the float. That got rid of some of the little glitch at the beginning of the sound. So the 0 message from rewind goes to the right inlet of float. Okay. Now, I changed the slider here. It's now going back from -1 up to +1 because I redid the calculations on playback speed. So here on playback speed and calculations, this is what I did. And basically it's like receiving the playback speed send from the slider goes to a Moses 0. If it's below 0, it gets multiplied by -10. So on its range from close to 0 down to -1, it gets multiplied by -10. It ends up being a range of like close to 0 up to 1. And, the one thing I do have to make sure is it cannot be less than 1. So I'm changing this again. Because this is slowing down. This needs to go from our normal speed of 100 to upwards. And it gets multiplied by normal speed here. So the lowest thing this should be is 1. Basically, we could put -9. And then a +1. That way it's going to be going from 1. Oh, not tilde. Get that out of there. It's basically going from 1 up to 10, getting multiplied by normal speed. So that means 100 up to 10, up to 1,000. And that you'll hear the effect of the change of speed in that. So then here, if it's at 0, we have a select 0 here where it'll bang a 1 if it's at 0. If it's detected that the slider's at 0, it'll bang a 1. So 1 times whatever the normal speed is, which is 100, is going to be 100. And then here, if it's not 0, that's the other outlet unselect, then that means it must be above 0, between 0 and 1. So we swap 1 to invert it. 1 minus 1, of course, is going to be 0. We need to add one little extra thing here too. Yeah. Swap 1, but down here, we should make sure, because this really should be, this is giving us an inverse. So it's 1 minus 1. That means it's basically going from, if it's all the way up at 1, it's a 0. If it's all the way down close to 0, -0.1 or something like that, it's like a 0.9. This is not the direction we want to go. This is not the way. I am sorry. So we're going to fix this up live. Well, we're close. We are actually close. The thing is, because this gets multiplied by 100, we basically want it to be we're going to have to do this. Just put a plus 0.01. Okay? The whole thing is this is going backwards because basically, 100 milliseconds, if you go higher than that, you're going slower, which is this side. If you're going lower than that, you're going faster, which is higher speed, which is this side. But these are higher numbers here, so you have to invert things and contort things around and make sure as it gets close to the middle, close to what's actually 0 on the slider, you're getting closer to 1. Okay, so let's test it out. I mean, the other stuff's working. All we gotta do is test out the playback speed. Hold on, just reset it. Oh, I can hear one more fix. It's right here. Playback when I took this out. Gotta put it back in. This 0 not only goes to the right inlet of... I should probably stop playing. Okay, so you see, I had to put this back in. When I resumed from pausing, I got rid of this. This had to go back in. Basically, when we rewind, it needs to put it down here to the counter as well as up here in the float. So they're starting from 0. There's no conflict between what's stored in the float and what's coming in here. It basically gets rid of that rewind sound. But now you hear how things are stuttering. That is because of down here. The line tilde things I had in here. That would have smoothed it out. Like basically when we get to the end and you hear the stop and then start again, this would have cleaned it out. So I'm going to work on that for next time to research it because I've used that plenty, like tons of times before. And I have no idea why it wasn't working today. So anyway, at least now this is it for today. One last just look at the playback screen so my students can get it. And get the patching right. So, maybe take a screenshot of that. Make sure it's all correct in your patches. And then I'm going to go over here to calculations. And maybe take a screenshot of that, making sure it's all correct in your patches. But that's it. That's what I needed to do. Just to get this stuff all working right. It was a bit of a trouble. I've always, whenever I make these things, and I've done it this way before plenty of times, I haven't had this much trouble like I did this time. I guess it's just been a while. But in any case, I'm going to take a screenshot. There we go. We're done for this week. Next week, we're going to add the start and end loop points as a feature. Right now, it goes between beginning and end. I basically want to put in sliders here so you can indicate a beginning and an end to where you want it to loop in between. And then that way you can turn the loop on or off. And when you're looping, it's looping between points you set. Alrighty, so that's what we'll be doing next time. Take care and stay free.